Good morning, everyone. How you doing? It's Dr. Izzy. Figured I would make it a little bit more personal if you can see me in action. Um, so before anything, just to get your attention, I'm going to go over week one material. Number one, do not fast forward anything, because I'm going to give you some valuable information on your assignment and assessment. So what you're looking for is what information can I provide that can help you, right? Otherwise, you're just going over, all the readings and you're going over all the videos, and that adds up to a lot of time, right? So I'm going to give a condensed breakdown. If you notice, I posted this PowerPoint under the learner uh, tools, right? The learner student tools, right? So, and if you read it, you realize I bolded a lot of information. So whatever I bolded, make sure you make a flashcard of it and study it. Make sure you absolutely know those concepts I bolded prior to taking the assignment or the assessment. Do not take the assessment or the assignment unless you've watched this video and or studied the PowerPoint I provided, right? So what makes my PowerPoint different? There's no paragraphs. This is a different look of the information, right? Um, your book has paragraphs. The videos have paragraphs. I have flowcharts and Venn diagrams. All right, and how does that help you? Well, if you're not into reading 1,000 paragraphs, all you'd have to do to study for this exam would be to practice my flowcharts and my Venn diagrams. Yes, I created every single one of these slides. These are my flowcharts. These are my Venn diagrams. Anyway, enough of the intro. I mean, you have my biography, um, which I posted under announcement. Let's get into the material so I can get going here. All right, number one is a flow chart of the subdivisions of anatomy, gross anatomy, right? Which is basically cadaver, you know, studying the cadaver, which I did for many years, and of course, there's microscopic anatomy. I think for your discussion, a few of you picked, the breath biopsy. I mentioned the Pap smear at one point, and that would be an example of microscopic anatomy. What's bolded here is, the definition. It uses a microscope to see the minute details of organ parts, right? Micro is a prefix meaning small. Scope is an instrument to measure. IC means pertaining to. Pertaining to an instrument to view small, right? Um, cells, right? Or small structures. All right, so that's the biggest takeaway behind this. Something else that's bolded here is biology. What's bio? Life. What's logy? Study of all forms of life, right? So study these slide, but absolutely make sure you know the things that I bolded here for you, right? Make sure you know the bolded uh, information, right? Let's move on. Body cavities. So you have the front, aka anterior. You have the back, aka posterior. What's bolded here is the dorsal, right? Dorsal includes the cranial and the spinal, right? The cranial contains the brain, the spinal contains the spinal cord. So, the dorsal cavities in conjunction would contain the organs of the central nervous system. What comprises the central nervous system? Brain and spinal cord. And they're both located where? In the dorsal cavities, cranial and spinal. So I wrote it here verbatim, right? Contains the structures of the central nervous system. Make sure you know that. And under the thoracic cavity, I wrote down some organs here found in the thoracic cavity. Make sure you know that. Make sure you make a flashcard. Make sure you know it. Let's move on. Directional terms. Make sure you know all the directional terms, right? Which I listed here as a flow chart, right? But I have the proximal and distal here. Hold on, guys. Can you guys see my screen? Yeah, I am. Yeah, you can see it. All right, good. So make sure you know the what proximal is, nearest to the point of attachment. Proximal basically means closer to the trunk, right? So wrist and shoulder, which one's proximal means which one's near the trunk. Shoulder compared to the wrist, right? Now, shoulder and elbow, which one's closer to the trunk? Shoulder. So the shoulder is proximal to the elbow. Wrist and elbow, which one's proximal? The elbow is proximal to the trunk compared to the wrist, right? Now hand and elbow, right? So the elbow is proximal, which means the hand is distal, right? The hand is distal to the elbow. All right, correct that. Actually, let's write distal here. The hand is distal to the elbow. All right. Know the coronal plane divides the body into front and back, right? Anterior and posterior. Know what medial means. So there's an imaginary line in the middle, and it means towards the midline. What does superficial mean? Well, towards the surface, as in a scratch on your thigh, right? All right, so no proximal distal for sure. Know the coronal plane. Know what medial means. Know what superficial means for sure. Let's move on. Homeostasis is the internal balance of the human body. Why do we care about homeostasis? Vital signs, right? So the body has an optimal temperature, right, that it works at 97.6 to 99.6. It has an optimal blood pressure. It has an optimal blood pH. It has an optimal heart rate. So homeostasis is basically our internal balance, right? The definition I want you to know is ability of the body to regulate the internal environment, right? Know that definition. Here's a Venn diagram, right? Comparing two concepts, organic, inorganic. What makes organic, organic? What makes the body, what makes something inorganic, right? The body's 2/3 water, right? So 66%. And water is inorganic. Why? Has no carbon. What does it have? H2O. What's H2O? Two hydrogens, one oxygen. So what is organic? Whatever contains carbon. Proteins are organic. Is there protein in our body? Yes. Hormones, most of them are proteins. And our enzymes are proteins. Our cell membranes have proteins, as you know from your notes, right? Fats are organic, right? Do we have fats? Yes, our cell membranes have fat. Our fat is a storage of energy, right? Anyway, it contains carbon. So that's what I bolded. Organic compounds contain carbon. Make sure you know that. Here it's reinforcing that, right? Carbon is found in, and I list the examples: proteins, carbohydrates, fats, right? Here's water I just alluded to. Make sure you know that organic has carbon. So protein is considered what's called a macromolecule. That's a big molecule. When we eat food that has protein, we need to break it down into the subunit and absorb it into our bloodstream. Um, so when we eat protein in our diet, we have enzymes that break it down and turn it into amino acids. What are amino acids? Molecular units that work together to build protein in the body. Here's a cell structure. The cell is the basic unit of the body, as you know from your notes. There's a cell membrane, which is a barrier between, the inside of the cell and the outside. And it allows some things to go in, some things to go out, and therefore that is a selective semi-permeable membrane. It's bolded, guys, so make sure you know the bolded, right? Make a flashcard, know the bolded, right? I also bolded the cytoskeleton, right? Internal framework of the cell consisting of microtubules, intermediate filaments, and microfilaments. So the cell has movement, right? And, that's known as cytoskeleton. Our intestines have brush borders propelling food, right? That's called cilia, right? Our lungs or airway tract has also cilia trapping dust particles. That is also cilia, right? Sperm for men have flagella, which allows it to swim. That is a cytoskeleton, right? Then we have mitochondria here, right? Where most of our energy is produced. Why do we eat? Why do we eat? Because they're not, body needs protein, fats, right? And carbohydrates. Yeah, but why do we eat, right? From a cell perspective, we eat because we need glucose to make energy, right? What keeps us alive is that production of energy. So the cell needs two things to make energy: glucose, right? Sugar, and oxygen. So that's why we breathe, that's why we eat. And what we need to live is to breathe and to eat. Why? Because the cell needs oxygen and glucose to make energy. What part of the cell needs glucose and oxygen to make energy? The mitochondria, right? Make sure you know that. It's bolded, guys. I bolded it for you. Most of the cell's energy comes from the mitochondria. So make sure you know mitochondria. Move down. Cell respiration. Now, there's nothing bolded here, so what does that mean? That means I'm trying to reinforce a concept. What concept am I trying to reinforce? The one we just talked about, which is the mitochondria makes most energy. So 34 ATPs, right? So what do we get out of one glucose molecule? 36 to 38 ATPs, depending on the textbook you're reading, right? But 34 of that comes from something called the electron transport chain, which is located in the mitochondria. Actually, this as well, right? The Krebs, right? Krebs only generates 2 ATP. Electron transport chain generates 34. That's 36 alone coming from the mitochondria. Is there any energy coming outside of the mitochondria? You said most, but you didn't say all of it. Well, here it is. 2 ATP is coming from outside of the mitochondria, specifically in the cytoplasm, right? So this is just delineating, reinforcing the fact that the mitochondria has is the area where is the organelle, right? Structure of your cell that makes the most energy. What's energy? ATP. What's ATP? Adenosine triphosphate. What do we need to make energy? Glucose and oxygen. Is that why we breathe and eat? Yes. All right. Nothing bolded. Just know that the mitochondria is where most energy is produced. All right. This one's reinforcing the exact same thing. So it's been covered, right? So if you kind of connect the last two Venn diagrams, remember 36 of the 30 ATP came from the mitochondria, but it needs oxygen, right? So in the absence of oxygen, we would probably be able to generate 2 ATP, and we would not be able to generate the other 36. Can we live with 2 ATP for a few minutes? All right. Vesicular transport, know what phagocytosis is, ingestion of foreign particles. Phago means cell eating, cyto means cell, osis means condition of cell eating, right? Why do we care? Well, because when you do a complete blood count, which is a blood test, there are white blood cells that actually phagocytize. They're called macrophages. What's a macrophage? Well, it's a monocyte at the tissue. What's a monocyte? It's a type of white blood cell. But that's coming up later on, right? For now, just know that phagocytosis means cell eating, but I gave you a definition here, so you study in your flashcards. Phagocytosis is the ingestion of foreign or other particles by certain cells. And then you have pinocytosis, that's basically cell drinking, right? But the process of engulfing large molecules in solution and taking them into the cell, right? Know those two definitions. Here I gave you a Venn diagram, kind of comparing phagocytosis to pinocytosis to receptor-mediated endocytosis, right? Cell eating, cell drinking, right? Let's move on. Solutions, right? So clinical application of this is something called normal saline. Why do we give someone normal saline? Because our blood has a certain osmotic pressure. Is that the force created by the amount of solute? Yes, right. And I wrote it here in it's bolded. Osmotic pressure determined by the solute. It's the pressure exerted by the flow of water through a semi-permeable membrane separating two solutions with different concentrations of solute. Solute is basically solid, right? So what solid are we talking about? Albumin. What's albumin? Protein. Is that found in blood? Yes. Is that the most abundant plasma protein? Yes. Is it the only? No. What else do you have? Well, you have globulin as well, right? Which is an antibody, right? But albumin is the most abundant. And that albumin, that protein, is creating a pressure. And the pressure in the blood is equal to 0.9%. So what is normal saline? 0.9% sodium chloride is what normal saline is. So when you're doing a normal saline infusion, that normal saline solution has to equal the osmotic pressure of blood. Therefore, normal saline is 0.9% sodium chloride, which is exactly the osmotic pressure of blood. Anyway, to not make it too complicated, know the things that I'm bolding here. What are the common states of matter? Gas, liquid, and solid, right? Although for this slide, the most important one is solid. What's creating osmotic pressure is solid concentration, right? And that's the definition of osmotic pressure. It's bolded. Make sure you know that. Let's move down. Here I'm comparing diffusion to osmosis. Diffusion is going from high to low concentration, right? High to low concentration. And then osmosis moving through low to high osmotic pressure, right? There is a bolded, I think, later on, but let's move on to the next topic: replication and transcription, things that happen in the cell. Replication, it occurs when an exact copy of each nuclear chromosome is made during the early part of the first stage of mitosis, early interphase, right? Make sure you know that. Here's mitosis compared to meiosis. So, what is mitosis? You cut your hair grows back. Why? Mitosis, cell division. You have the skin cut, then it grows again. What is that? Mitosis. You cut your nails and it grows again. What is that? Mitosis, right? Our skin is shedding off all the time. What is that? Mitosis, right? So mitosis has to do with cell division, right? And as it says here, it replaces dead or injured tissue, right? That ability to regenerate is mitosis. A fractured bone heals, that is mitosis. Anyway, when we talk about sex cells, sperm and the ovum, that is known as meiosis, right? So with meiosis, as you see, I bolded it, there's a reduction of the number of chromosomes and it occurs in sex cells. I'm sure you know that. There's a few questions about cancer, right? So know the definition of metastasis, the process by which malignant tumors spread to other parts of the body. Spreading is a key word. Spreads. Meta is a prefix meaning beyond. Stasis means standing still. So it's moving beyond a focal point. Apoptosis, orderly process by which the cells intentionally dies, right? So apoptosis is natural. Remember, I just mentioned the skin sheds off every now and then, right? And then we have to make new skin. That's apoptosis, right? It's a programmed intentional death. Hypertrophy, when a cell increases in size, and tumors when cell division does not occur in the usual pattern. I think in one of the discussion replies I made, I said tumor happens when there's uncontrolled mitosis, right? Same thing. So when cell division does not occur in the usual pattern, right? Anabolism, catabolism. I mentioned earlier that when we eat food, we break it down with enzymes. When we eat proteins, we break it down into amino acids. Therefore, amino acids is a subunit of a proteins. Therefore, amino acids would build protein. So kata is a prefix meaning to break down, right? Catabolism. But the body also has the ability to build up, right? And that's called anabolism. And one example of a hormone that is anabolic is insulin, guys, right? Insulin doesn't tend to break down things, it tends to build up things, right? So when we don't transport sugar into the organs, insulin turns that sugar into fat. Yes, that's the reason why patients with diabetes type 2 gain weight is because of insulin. Anyway, anabolism is the building up of complex materials from sibilants, such as food and oxygen, right? So the other thing we build up is glycogen. So we store glucose because we're not eating all day. So where do we get glucose when we're not eating? Well, we have storage of glucose. Once we're done with the glucose we get from diet, we're able to go hours without eating because we have a storage of glucose called glycogen, which is found in the liver, right? Mainly. But we have hormones forming glycogen, right? Same thing with that fat I just mentioned. If we keep fasting, our body's going to break down that fat and convert it into glucose, right? Which is kind of the mechanism behind losing weight and exercise. All right, so you have several questions on pH. Listen up to this recommendation. I think in your notes and your other PowerPoints, they list a bunch of examples of pH. Make sure you know that, guys, right? stomach pH, tomato sauce. Um, uh, I think they have magnesium hydroxide. Blood. The one I listed here was blood 7.4. Stomach acid, which should be about 1, right? But make sure you're pretty much familiar with the different examples of pH. Go back to your notes. Make sure you know that. Make sure you also know that base is also known as alkali. Our blood has a 7.4, which means it's slightly basic, right? Water is neutral. As you can see, it's right in the middle, right? So when you have a lot of hydrogen, that makes something acidic, right? The stomach makes hydrochloric acid, and that's a very strong acid, right? So that's going to be closer to 1, right, or 0. Um, and then we have, alkaline, which is right over 7. Any pH over 7 would be considered alkaline or basic. And the reason this is relevant is because in our body, we have this reaction all the time, right? Our body makes hydrochloric acid in the stomach, and we need that hydrochloric acid, as you will see later on, right? We need the hydrochloric acid to activate enzymes. We need that hydrochloric acid to break down food. We need that hydrochloric acid to absorb nutrients, right? Like calcium, like iron, right? But it's such a strong acid that once it reaches the small intestine, our body also makes bicarbonate, right? So sodium bicarbonate would be considered alkaline, right? Whereas the hydrochloric acid is considered acidic. So the acidity is only in the stomach. Once it leaves the stomach, goes into the small intestine, the duodenum, then it gets neutralized by bicarbonate, right? And that's relevant for patients with peptic ulcer disease. That's relevant for absorption of certain nutrients, like I mentioned. And it's relevant because even our blood has a certain pH, which is 7.4. Make sure you know the examples of pH from your notes, right? All right. Here's amino acids. I talked about this earlier. I said it was the building blocks of protein. It's right there. Make sure you know that. Cell cycle interface, right? This is basically, well, mitosis and meiosis undergo some prophase, metaphase, anaphase, telophase, but there's a resting state called the interphase, right? The coronal plane, I talked about this earlier, divides into front and back, anterior, posterior. Even when I talked about cavities earlier, I talked about, hey, look, you have some dorsal cavities. That's posterior cavities, right? And what you needed to know for that slide was that the dorsal cavities, cranial and spinal, contain the organs of the central nervous system. Let's move on. Protons and electrons. Protons are positive, electrons are negative. What I bolded was the number of protons in an atom equals the number of electrons, right? Why is this relevant? Because if we expand on the conversation, why do you breathe? Why do you eat, right? I said we eat because the mitochondria of the cell needs glucose to make energy. Remember that? Okay. It's kind of important to know why we're eating, right? It's not just because we're hungry. It's a physiological need to make energy and stay alive, right? But having said that, the second thing I said was we need to breathe. And well, what do we need from air? Oxygen. But why oxygen if we have so many gases, right? Remember, we talked about the states of matter, solid, gas, liquid. There's a lot of gases in the air. In fact, oxygen is not the most abundant gas in air. It's nitrogen. By far, right? Nitrogen is over 70% of air, right? Oxygen is roughly 21%. And then we have the other gases, right? But why do we need oxygen and not nitrogen? Well, I don't want to make this a chemistry lecture, but nitrogen's in group 5 of the periodic table. Oxygen is in group 6. So, well, I don't know if you remember this from chemistry, but if you're in group 6 compared to group 5, group 6 has a better ability to attract electrons. It's more electronegative. So, well, that's why we need oxygen to live, right? Oxygen is a good electron acceptor, and that electron attraction is critical to making ATP. If you look at my slides, at some point, did I say electron transport chain makes 34 over 38 ATPs? Yes. Guess who's exerting the force to attract those electrons? Is that oxygen? Yes. Can we live without oxygen? We'll see how far that'll take you. A couple of minutes. In the presence of oxygen, if you look at my Venn diagrams, we make 34 of the 36 of the 38 ATPs. 2 ATPs is not compatible with life, guys. 2 ATP would buy us a few minutes. We need oxygen to live, right? And the reason it's oxygen and not nitrogen is because of oxygen being more electronegative and having a better ability to attract electrons. So that's why this is relevant. All right, make sure you know that. Cytoskeleton. Oh, I already talked about this. Here I'm just kind of expanding on it. But make sure on the previous one where I bolded cytoskeleton, you know the information I bolded there, right? Lipids. Yep, so fat is an example of lipid. What's the function of fat? Insulation? What do you mean, like keeping temperature? Yes. But it's also a big part of our cell membrane. And why are membranes a barrier, right? If our cell just allowed everything to come in, then, you know, it would swell and burst, right? But it has a barrier, and part of it has to do with the fat that's found in the membrane, right? Remember, one of your, flashcards says selective semi-permeable membrane. But fat's also a storage, right? So if we have fat in our body and we fast or we exercise, we're going to keep burning glucose from our diet. And then we're going to burn glucose from glycogen, which is our storage of glucose. And once we've used all that, we're going to start burning fat. And that's the reason why we lose weight with exercise, right? Because our body would start breaking down fat to convert it into glucose. So our mitochondria makes ATP, which is energy, right? So make sure you know fat is an example of the lipid. Here it's a comparison between fat, steroids, and phospholipids. Also keep in mind some of our hormones are fat. Progesterone, right? Aldosterone, cortisol, estrogen, thyroid hormones, right? They're all fats. And that wraps it up, guys. So I just wanted to give you my intake here on the PowerPoints I made myself, right? If you have any questions, contact me. Please watch this video before taking your assessment and assignment. Please make flashcards of the PowerPoint with everything I bolded. Make sure you know the information from, the videos that are provided and the readings from your book. Good luck, guys. I'm here to help. I'll probably be doing a video for your week 2 as well. So I'll see you later. Thanks, guys.